So we have moved things left and right, up and down already. Now we're going to look at what do other things do to our graphs. What happens when we have negatives? If we have a negative outside of the graph, that graph gets flipped down. If we have a negative inside of the graph, then the original red graph got flipped over. So we're going to make a little bit of extra notes with this. And you're going to write it right beside. I don't have quite as much room to write it right beside. So I'm going to write it here below. And we're going to start with having a graph that has y equals f of negative x. So negatives have the power to flip things. Sometimes things are flipped over the x-axis. Sometimes things are flipped over the y-axis. So if the negative, and we're going to use the same language that we've been using all the way through, if the negative is inside the function, if the negative is inside the function, aka with the x, inside the function with the x, it will reflect horizontally over the y-axis. So one of the things we noticed with translations is when we had values inside the function, they moved things horizontally, left and right. When we have a negative inside the function, it's also going to act horizontally. And so if I had the point 4, 3, when it gets reflected over the y-axis, it's going to be negative 4, 3. And your x value gets changed. And that's going to be a pattern that we see over and over again. Things inside the function are going to affect our x-coordinate. Things outside of the function are going to affect our y-coordinate. So similarly, we can write for y equals negative f of x. Notice that negative is outside. So if the negative is outside the function, then the graph is reflected vertically over the x-axis. Again, if we think about a specific point, if I have the point 5, 2, reflecting that vertically, that's just going to change my y-coordinate. And we're going to multiply our y-coordinates by a negative 1. So same as before, and this is going to be a theme that follows through in all the different transformations that we do. Okay, we've started off with translating things left and right. We're adding reflections. Next, we're going to stretch graphs and compress graphs. And finally, we're going to put all of these things together. What happens inside of a function affects the x values, affects things horizontally. What happens outside of the function affects the y values, affects things vertically. So that's going to be a common theme that's coming through, and today we're just looking at what happens with reflection. So let's go to example 1 here, to the one off the side. Here's the graph of g of x. We want to sketch the image graph, so we've already learned that word and what it means, with a reflection in the y-axis, and state the domain and range. So reflection in the y-axis is going to be a horizontal reflection, because we're going to take this value here, which is at -3, 1. If I flip it over the y-axis, it's going to go over here to +3, 1. So we can do that with each of our points. The next one would be, this one would go over here, this third point would go over here, and this point would go over there. Connect the dots. Look at your final image and ask yourself, sort of as a verification, does that look like the right shape? Does it look like it has been flipped over the y-axis or in the y-axis? Now, if I wanted to write the equation of that blue graph, the equation of that blue graph would be still g of x, but would I put a negative with the x, or would I put a negative out in front? With the x. Because when I think about going over the y-axis, it's horizontal, it's affecting my x values. Okay? But this is going to be one of the parts where you can see your brain wanting to put it with the y values, not with the x values, because you hear the word y-axis, right? So it's kind of like tempting you. Put it with the y, put it with the y, right? But it's horizontal, it's going over the y-axis, means if I think about a specific point from here to here, which coordinate has changed? It's the x coordinate that changes. This point on the red graph is -3, 1. This point on the blue graph is +3, 1. It's the x coordinate that's changing, so our negative goes with the x. State the domain and range of each function. I'm going to use interval notation today. So with our blue graph, what's our smallest x value? -5. What's our largest x value? 3. For our range, what's our smallest y value? -2. What's our largest y value? +2. On our original graph in red, this is where the color coding is nice. The domain of our original graph went from -3 to +5, and our range of our original graph still went from -2 to 2. So what we have opening up for us are a bunch of questions that could be asked. So we've learned one little concept, but now that concept could open up many kinds of questions. We were able to figure out the domain and range because we had the graphs. But if I took away the graph, and the question said, here's your original domain and range, and you reflect it over the y-axis, could you find these blue domain and ranges without having the graphs? Okay? Well, you think to yourself that what's happening, my x values are getting multiplied by a -1. Can you see that connection from here to here? That I went from -5 to 3, and when those got multiplied by a negative, we now go from -3 to 5. But that's a little bit more abstract than when we had the graphs. When we had the graphs, you just would go back to like, oh, I'll just see it from my graphs because that's easiest. But that's what's going to happen in this course, is I'm going to ask you to be able to do those things by taking one part out. You see our range didn't change? Why doesn't our range change? Well, if you think about this, the negative is just with the x. It's only affecting the x coordinates. Your y coordinates aren't getting changed. So your range stays the same. Okay? What is the easiest hard question that I could do in something like this? I could give you this and say, what's the new range? Would it be hard for you to write the same thing again? That happens sometimes. Be like, it doesn't change. That's so hard for me to write an answer that nothing happened. Okay? Sometimes those questions come up. Or they'll ask you for the domain and range. In this case, the range doesn't change. But I find for myself, those are the hardest questions, where you feel like, okay, they just asked me a question, it seems way too easy. Have you ever had those questions? Where it seems way too easy, so it can't be the easy answer, and you go and create some complicated math to come up with a very sophisticated wrong answer, and you write it down, and then you get your quiz back and you're like, it was the easy answer? So don't second guess yourself too much. Okay, questions we can do for practice on this one are 3 and 13.